Good day, grade 12 matriculants incorporating students who are upgrading their matric. Today we are going to be discussing subtropical anticyclones, and also a good day to other fellows, people who are curious in learning more about geography and geography teachers. Okay, today we are going to be discussing a lesson under subtropical anticyclones. Yes, as you already see that I've done a diagram so that I can explain better. So for us, in order to understand again these subtropical anticyclones, we have to understand the movement of the winds, of the planetary winds around the world, as you can see in my illustration there. Okay, you know, this is the equator. This is 0 degrees. This is the ITCZ. ITCZ, where tropical cyclone form. Yes, have you already discussed mid-latitude cyclones, tropical cyclones, and now we are discussing subtropical anticyclones. This is 0 degrees ITCZ, where tropical cyclones form. And this is 30 degrees north of the equator, and this is 60 degrees north of the equator, and here we have poles. This is 90 degrees. Here we have 30 degrees south of the equator. Here we have 60 degrees south of the equator, and here we have 90 degrees south of the equator, which are the poles. Okay, let's just get into the point. This is ITZ, intertropical convergence zone. This is served by tropical easterlies, and another tropical easterlies come together with a force of converging. That's why it's said to be as convergence zone. Yes. So as these tropical easterlies, you can see tropical easterlies in our tropical regions, they come together, like they converge. As they converge, they will cause a low pressure in the ITCZ. That's why we're saying this is a low pressure belt. This is a low pressure belt here at the ITCZ. Okay, let's go down. And if we are doing something under the equator, that means 30 degrees south, it's also the same, 30 degrees north, 60 degrees, yes. So here, as you can see, on our 30 degrees south as well as our 30 degrees north, the air movement is much more different than in the ITCZ, because you can see they are moving apart. The tropical easterlies are moving apart from the tropical westerlies. The tropical westerlies are going down. These are the tropical westerlies are going down, and these are the tropical easterlies are moving apart, causing high pressure in 30 degrees south of the equator. So this is a high pressure belt. High pressure belt. This high pressure belt, you can see this is where our mid-latitude cyclone form in the polar front. Here you can see there is convergence between the polar easterlies and the tropical westerlies, causing the low pressure belt here. It's a low pressure belt, I can say. Yes, a low pressure belt. It's a polar front. You can say it's a but let me say it's a polar front, whereby the different masses meet together. It's a polar front here. You can say it's a low pressure. You can say it's a low pressure. It's a low pressure belt. And then here we have polar high. There's high pressure because in the poles there is polar high. There is polar high. Polar high. Okay, yes. So again here we have 30 degrees, we have high pressure belt. It's a high pressure belt. Here it's a low pressure belt, it's a polar front. Polar front, which is a low pressure. Low pressure belt. It's a low pressure belt. Now, okay. Also here polar high. Okay. So I think you can see now that the tropical cyclones with the mid-large cyclones are said to be as low pressure system, or it's a low pressure cell. Why it's a low pressure cell? Because they form in the area or in the regions where the air masses converge to each other, causing a low pressure. You can see in tropical cyclones, in tropical regions, which is the ITZ, and also in the polar front, they come together, which can cause low pressure. But now we're discussing subtropical anticyclones. You can see it's high pressure belt. That means a subtropical anticyclone, if it forms in 30 degrees south and in 30 degrees south, or in some subtropical regions such as the upper mid latitude regions, I can say, particularly here in South Africa. So in subtropical regions, we're discussing a fundamental climate in South Africa. Yeah? Okay. So this means that high pressure belt is caused by this diverging air. So let me just give you some notes of diverging air and converging air, right? Yeah. Okay. Converging air is like this. This is converging air. These are two masses. Converging air. This is converging air, right? This is converging air, and this is diverging air, moving apart to each other. These ones move closer to each other, moving apart to each other. This is diverging air, or diverging wind, I can say, yeah. So you can see diverging air causes high pressure. Converging air causes low pressure. Yes, converging air causes low pressure, then diverging air causes high pressure. What does this mean? Let's break it down again. So by breaking it down, we're going to say, we're going to first discuss the converging air. For instance, in polar front or in ITCZ, there is converging air there causing a low pressure. How does that happen, or how does that? Okay. Converging air will be like this. Let me start here. If the air moving to each other, they will cause a low pressure, as I said. The warm air will be pushed to rise, and the cold air will get underneath, right? Yes, because warm air is humid air, has humid, causing to rise. The higher it goes, the colder it becomes. Then this warm rising air meets the dew point, it starts the condensation process. So it starts to condense, changing its states from gas to liquid by forming clouds. So this means by forming clouds, this can cause rain. These are clouds. A rainfall can happen. Yeah. So a low pressure, which is converting air, causes a low pressure. So let's get to diverging air. So this is diverging air, I can say here. This is diverging air, moving this side, this one moving this side. They are moving apart to each other. They are not moving closer to each other, or they are not converging. So diverging, it's an opposite of converging. So when two air masses diverge, they cause high pressure. How? The air in the upper atmosphere, or the air in the atmosphere sinks down. The air in the upper atmosphere sinks down or descends. So as it descends, this air, the higher it goes, the colder it becomes, or increase with an altitude is a decrease with temperature. So this air is very, very cold in the atmosphere. You can say this is the atmosphere, and therefore the higher it goes, the colder it becomes. If the higher it goes, the colder it becomes, that means a decrease with an altitude is an increase with temperature. So as this air descends, it will hit adiabatic with the adiabatic elapse rate of 1 degree per 100 meters. So it will go down, causing high pressure. Causing high pressure. Okay, yeah. So this will hit 1 degree Celsius per 100 meters. So as this air from the atmosphere goes down, it will increase its temperature with 1 degree Celsius in 100 meters. Yeah. So yeah, that's it. Yeah. So basically, these are subtropical anticyclone we're talking about. This is how subtropical anticyclone form. This is part of it. They occur in winter, mind you. Subtropical anticyclone in winter. In the interior of South Africa. So, and then these anticyclone, as they are caused by high pressure, or I can say they are high pressure salts. So they're moving in an anti-clockwise direction. So they are moving in an anti-clockwise direction. Moving in an anti-clockwise direction. Yes. So maybe you're asking yourself, as I said maybe before, that tropical cyclones as well as other cyclones which are midnight cyclones, they move in clockwise direction in southern hemisphere. Maybe now you're shocked or you're surprised by me saying that these anticyclones, they are okay in southern hemisphere, which is in South Africa, but they are moving anti-clockwise direction. Okay, how does this happen? It's because now the system has changed, because it's a high pressure system. It's not a low pressure system. It's not moving upwards. The air is not moving upwards. Like the air is not moving upwards. It's going down, causing high pressure. It's not moving upwards, causing low pressure. Because if it was moving upwards, it was going to move in clockwise direction like this. Clockwise direction, yeah, clockwise direction, yeah. So now the air is moving down the interior of South Africa, causing high pressure. So it's going to move in an anti-clockwise direction. In an anti-clockwise direction. It's going down. It's going down. It's going down. It's going down. You see? It's moving in an anti-clockwise direction, causing a high pressure. It's a high pressure system. Yeah. Yes. So this all means that maybe with the understanding, maybe you must already know that this is, okay, I can say in northern hemisphere, this is northern hemisphere. This is northern hemisphere. Okay, let me just say this. And this is southern hemisphere. This is hemisphere. The southern hemisphere and northern hemisphere. So, not to confuse you, this in northern hemisphere, a high pressure system. Let me say a high pressure system. This is a high pressure system, and this is a low pressure system. This is a high pressure system in southern hemisphere, and this is a low pressure system. So a high pressure system in northern hemisphere will move in clockwise direction, in an opposite direction than they do in southern hemisphere. They'll move in clockwise direction. In northern hemisphere, a high pressure system in northern hemisphere will move in clockwise direction, not in an anti-clockwise direction. So sorry. In southern hemisphere, they will move in an anti-clockwise direction. In southern hemisphere, this is a hemisphere that we are going to be more detailed, more talking about, because South Africa is in the southern hemisphere, yeah. Then the low pressure system in northern hemisphere will move in an anti-clockwise direction. In the hemisphere, anti-clockwise direction. Then in southern hemisphere, they will move in clockwise direction. This is anti-clockwise, and this is clockwise direction. Move in clockwise. Yes. So to summarize, in northern hemisphere, a high pressure system or a high pressure cell, I can say, which is caused by diverging winds, will move in clockwise direction, a high pressure cell. Then a low pressure cell in the hemisphere will move in an anti-clockwise direction, which is caused by converging air. Then in southern hemisphere, they will move in an anti-clockwise direction, the high pressure cell. Then the low pressure cell will move in clockwise direction. Yes, that's it. Okay, now let's get into more details about these subtropical anticyclones. As I've already said, these subtropical anticyclones, they occur, and mainly we are going to discuss them upon the southern region, which is in South Africa, because 30 degrees south of the equator moves upwards in winter and downwards in summer. So now these anticyclones are more represented and are stronger in winter. So that's why we can say they occur or they affect the interior of South Africa, or the land of South Africa, or the surroundings of South Africa in winter. And that is why we say they occur in winter. Okay, we have 3 anticyclones. The very first one is Kalahari High. The second one is South Indian High. The third one is South Atlantic High. Okay, let's start to Kalahari High. Kalahari is also known as Kalahari Anticyclone. This is the anticyclone that is in the interior of South Africa. It is in the interior, like in the land of South Africa. Yeah. So it affects people living in South Africa more. And also we have South Indian High. The South Indian High is the one that is in the Indian Ocean, in the warm ocean, which is said to be warm Mozambique current. And the South Indian High, it's a warm ocean, and so on. And also with South Atlantic High, the air from there. And these anticyclones, these 3 anticyclones, 1, 2, 3, are the ones that represent a high pressure belt in South Africa, particularly in winter, in terms of the seasons. Okay, so as you can see, this 30 degrees, you can see this is the 30 degrees south. You know what happens on 30 degrees south. This is whereby our planetary winds or our global winds are diverging, causing high pressure. So this latitude has moved upwards in winter. So basically in winter it moves upwards, then in summer it moves southwards. If it moves up southwards in summer, that means also the equator will move up southwards, becoming closer to South Africa, causing hot conditions, causing a low pressure in South Africa, causing cloud cover in the sky of South Africa, causing heavy rainfalls during summer season in South Africa, and so on. That's the reason why. So as you can see, they are dominant now. It's winter. They moved upwards. They moved upwards. So this is 30 degrees latitude. So it's winter now. They moved upwards. The other thing that you should know is that okay, let me just give you notes. Write down the important factors that you must know are related to these anticyclones. These three anticyclones, they move northwards. They move northwards. They move northwards in winter. They move northwards in winter, and I can say, and they move southwards in summer. Okay, this means that if these three anticyclones, these three anticyclones, as I said, they represent the high pressure belt, the subtropical high, which is on 30 degrees south of the equator. So this 30 degrees south of the equator is right straight above or right through on the interior of South Africa. That means it lies on the interior of South Africa in winter. So if this 30 degrees south moved upwards, causing a high pressure in South Africa, that means also the equator moved northwards. Let me repeat for you. If this 30 degrees south of the equator latitudes, if this 30 degrees south latitude of the equator moved northwards, that also means that the equator has moved northward also, and also the polar regions or the polar front, I can say the line which is 60 degrees south of the equator had moved northwards. Also the polar regions or the poles have moved northwards. So if one latitude moved northward, that means all other latitudes are affected to move northwards. Yes. So, and therefore, in terms of weather conditions, if also the equator moves northwards, that means that we're far from the sun. That means the sun rays take longer. They take long distance to hit South Africa. Causing low temperatures. That is why also in winter we experience low temperatures. We experience a high temperature. We experience high pressure. In terms of the wind, you can see it's windy in winter and so on. And also in terms of the poles moving north, that means they are coming closer to South Africa, bringing cold weather conditions, bringing high pressure because there will be dry air, very, very cold and low temperatures in terms of the poles. So that's how it goes. I think you understand. So they move or shift, or you can say they shift. They move or shift northwards in winter and move or shift southwards in summer. So this all means that you can see the equator is just between, or it's in the middle of the world, you know. Yeah, it's in the middle of the globe. So if the equator is in the middle of the globe and moves northwards in winter, that means the regions or the northern hemisphere or the countries or regions in the northern hemisphere will experience summer because the equator is overhead them, is so close to them, but far from southern hemisphere. So if it's far from southern hemisphere, that means we're experiencing winter because the polar regions or the poles are so close to us. Yes, that's the other point. So if the equator moved northwards or upwards, we can say upwards. If the equator moved upwards, then the southern hemisphere will experience winter. So if the equator moved upwards, then the southern hemisphere will experience winter. I think you understand. You know, yeah. So it's a vice versa. If the equator moved southwards or downwards, the southern hemisphere will experience summer, and therefore the northern hemisphere will experience winter. If the equator moved southwards or downwards, then the southern hemisphere will experience summer. Yes. So if the equator moved downwards, the southern hemisphere will experience summer because now the sun rays, you know, the equator is overhead there. The sun is overhead the equator, and therefore if the equator moves southwards, that means the sun's rays are so close to us in South Africa, causing low pressure. You know, also the ITCZ will move southwards, you know, yeah, causing that a lot of rainfall and so on. You know, yeah, you know, if there's much heat, more humid air from dams, lakes, rivers, and also oceans will rise, causing a rainfall. But if the equator is away from us, we are going to experience winter. And this is whereby these anticyclones are overhead South Africa. You know, that means that 30 degrees south is overhead South Africa. You know, yeah. So this is whereby we experience winter, a high pressure season, and so on. And so in winter, there is a lot of subsiding air. You know, I already told you. In winter, there is a lot of subsiding air. Let's say this is winter, a lot of subsiding air. It's winter, this is subsiding air. Subsiding air. This is subsiding air, and this is winter. There's a lot of subsiding air to the land of South Africa. And this is the land of South Africa. Yeah, so this is winter. And in summer, in summer, there will be kind of like a low pressure because the equator, or I can say the anticyclone had moved downwards. Also, the equator will move downwards, causing a low pressure in South Africa. And therefore, if there's low pressure in South Africa, there will be more rising air than subsiding air. There will be more rising air. In summer in South Africa. And mind you guys, we're talking about South Africa. We are fundamentally talking about South Africa. This is rising air. This is rising air, and this season is summer. This season is summer. Yes. So if there's rising air, there will be a lot of clouds formed, causing rainfall. A lot of clouds formed, causing rainfall. But in winter, there will be clear skies. That is why also in winter there is clear skies. That is why. That's it. And so the most important thing that you should know is that all these 1, 2, 3 anticyclones, this is South Indian anticyclone, this is Karali anticyclone in the interior, and this is the South Atlantic anticyclone. You should know all of these, as you know that they represent this 30 degrees south of the equator, and this is the land of South Africa. I can